Hi guys, welcome to my channel AlgoCraft. In this video, I'll be solving one more problem from the Algo Expert site, and the problem name is remove kth node from the end of a linked list. Okay, now let's understand the what is the problem is. So problem basically state that you will be given the head of a linked list and you need to remove the nth node from the end of the linked list and return its head. So what is the problem basically state that let's say you will be given a linked list something like that, and you also given a n value is 2, so that's mean you need to remove the second node from the end of the linked list, so that is basically 4. So our answer would be 1 2 3 8 5. 4 is deleted, right? So how can you solve this problem? So to solve this problem, what is the basic brute force approach we can apply here? To remove any node from the linked list, what the things we basically need to know? We need to know what is the previous node position. So that means this three position we need to know. So this is the first. Uh, then like if we able to find out the what is the position of his previous node, then we can simply delete this connection and pointing to his next node, right? Then only this node is got deleted. So to delete this node, what is the things we need to do? We need to find out the position of his previous node. Okay, but how can we find out the position of his previous node? Okay, to find out the previous node, like if the in value is 2 given, that means so we need to remove the second node from the linked list, right? So and if we can calculate the what is the length of this linked list, then we can simply find out the what is the position of this node from the start, right? So let's say if we can calculate for can we calculate the position length of this linked list? Yes, we can, by simply iterating it one time, right? So then we can find out the length of the linked list is 5. Then if we could subtract it two times, right? Then mm, the position of this node from the start is nothing but 3, right? Because one, it is from the start position, it is in the uh, it is basically 3 plus 1, right? Because it is the position of this node is the fourth position, right? So but what is the previous node value? Previous node position, I mean, which is basically nothing but 3. So this position we are able to get to know, right? So then what we can simply traverse this list once again, and we'll reach to this position, and then we can simply remove this connection, right? So to remove this connection, like if we at the moment we are in this position, right? So this is if this are current node, right? Then to remove this pointer, we just simply do current dot next. Now pointing to current dot next, which is for to next, right? So current dot next to next. So this is the things we need to apply. Then only the fourth node will got deleted, right? Now this is not a optimal approach, because here we basically iterating the linked list two times, one for finding out the length of the linked list and another is find out the position to his previous node which needs to be deleted, right? So here the time complexity order of 2n, but uh, we need to solve this problem in order of n time complexity only. Okay, Now how can we solve this problem in order of n time? To solve this problem in order of n time, let's understand one scenario. Okay. Now let's say I have a total 6 node, right? 1 2 6. Now if and we need to delete the second node from the end, right? So this is the from the this position is from the last is 2, right? Now what I can do, if I initially go to this 2 position, okay, and total length of this is list is 6, right? So if I move this position at the beginning by 2 times, then what is the remaining times we need to traverse, which is nothing but 4, right? So this is 4, right? Now if I traverse initially 2 times, right? So I am now currently pointing to this position, right? Now at the same time I also start from here, and then the another point I also start from here, so simultaneously I will start both this position, right? Now once this position reach to the end, and this position now reach which position, which is nothing but fourth position, because from this position to this position is 4. So in that case, as this is goes till fourth position, so as we start from the same time, right? So it also goes to fourth position, right? And this 4 is nothing but our the node which next node to be deleted, right? So now let's understand with a proper example. Say I have 1 2 3 4 5 6. Okay, now I need to remove the second node from the end of the linked list, which is 5, right? So this node I need to delete, and from the second node from the end of the linked list, right? Oh, for that, initially our head is pointing to this, right? So this position. So what I will do, I will initially start move this pointer to 2 times. So if I move this pointer 2 times, so this is 1 time, and then another is an 1 time. So as of now, our let's say I consider this pointer as a first pointer. Okay, so our first pointer now at this position, right, at third position. Now what I'll do, I will take another pointer which is also pointed to at the beginning, okay? And now what I'll do, I will move these both two pointer, first and slow pointer, by 1 time till the first pointer reach to the end, right? So if I do this, so now first pointer move to one position, okay? So now our slow pointer also move to 2, right? Here it is now slow, there it is first. Then the first pointer move another position, so which is here, right? Then in that case our slow will at 3. Now first will pointed to now at 6, so this is where first is. Now slow will now pointed to 4, right? Now from this pointer, first pointer cannot go any further, right? So we are basically reach the first pointer to the end. And now what is the position of the slow pointer? Slow pointer is nothing but at pointing to the previous node, like previous position, from which the next node needs to be deleted, right? So basically we are able to reach to the previous node, to the node which needs to be deleted, right? So in that case our solo pointer now pointing to this 4, right? So if our solo, if in any pointer pointing to this node, then we can simply delete this 5, right? How can we delete this? We just simply initialize flow next, which is this pointer, and we will remove that, and pointing to flow next, which is 5, to next, which is 6, right? So basically I am removing this pointer and creating a this pointer, okay? So this way I can remove the nth node from the end of the linked list by one iteration, like order of n time, because at the first our if n value is 2 given, so at that time the first pointer only move 2 times, like order of 2, then the first pointer move order of 4. Okay, so total order of 6 times the first pointer move, and once the first pointer reach to the end, that time only it got completed, right? So total order of n time it take, right? So here the time complexity is order of n. Okay, so now let's I'm writing the, and there will be another catch. Okay, uh, so now let's say if I wanted to remove the mm, remove this node, like from the end I want to remove this six node from the end. So that's mean this is our first node that to be deleted, right? So in that case, so once when we start iterating, at that time only our first pointer reaches to null, right? So if first pointer is reaches to null, that means I will just like put another condition. If first is null, okay, from then only we just need to return the, like if I deleted this node, we just simply return the head to next, right? So this node in that case I need to delete it, I need to return, right? So we can simply do that. So I am writing the pseudocode here. Okay, so what I'll do, I'll take two pointer. So basically slow is pointing to head, and first also pointing to head. Okay, now what I'll do, I'll just iterate n time and move the first pointer. Okay, so what I'll do, I'll for I equal to 1 to I less than equal to n I plus plus, and I'll move the first to first dot next, right? Now if first equal to null, so first this is at null, first this is at null, that's been basically we tried to remove the first node from the start, right? So then in that case we just simply return the head dot next value. So that is basically, so if I wanted to remove this one, so in that case we just we just return the head dot next. So now our new linked list which basically start from here. Okay, so I just simply return it. Yeah. And if that is not the case, then what I'll do, I will also move slow and fast pointer simultaneously, right? So while fast dot next not equal to null, then I move both slow and fast pointer next, and slow equal to slow dot next. And once this while loop breaks, I will just remove the node, right? So to remove that, I'll just slow dot next equal to slow dot next dot next, and after that I will just return the head of the linked list, right? So this is the pseudocode. I will also provide the proper code in the description section, so please check it out, and please do subscribe my channel for more content. Thank you.